today is the introduction part. So welcome to the Linux Basics live course. This course is actually designed for anyone who has absolutely no information or no knowledge of Linux, or they have some basic knowledge of Linux and they want to get started and want to get more confidence basically in the Linux operating system world and how exactly we can do some of the basic stuff and a little bit of advanced stuff also. Like we are also going to cover a bit of networking. We will do a project also where we can implement some web server. So we will start from the very basics, but then soon you will see that you're doing quite interesting work as well, right? So first of all, let's understand what is the code structure, and then later we will introduce the Linux operating system itself and a little bit of history about that as well, right? So this course is designed with the plan with once a week, and this is going to be 2 hours per session. And although I always say that these courses are more topic driven, not time driven, so sometimes it can go slightly more than 2 hours, sometimes it might be less than 2 hours, depends on the topic of the day. And every week we are going to cover a particular topic, like maybe we will discuss about the directory structure, maybe we are going to discuss about networking, maybe we are going to discuss about some of the basic commands. So it depends on the topic, and that will decide how much time it is going to take, right? So this basic course is the live course. As you can see, every week we are going to meet into this Zoom session, and we are going to discuss about Linux, and we are going to see some configuration examples. So this course is specifically created for to be an 8 weeks course. That means we are going to meet 8 or 9 times live to cover some of the basic information about Linux. So although I'm saying 8 weeks, it might actually go a little bit more as well, depending on how much practice we need or how much time we need to complete the class. But roughly, it's a 2 months course or on an 8 week course, once a week. So basically 8 sessions. But of course, then you can continue with the 52-week live program. Sorry, the 52-week recorded program if you opted for that as well, which takes you all the way to the expert level as well. Now, this course is designed with one thing in mind, that it has to be completely hands-on, because Linux operating system is mostly CLI based. So of course, there is a lot of GUI as well. But if you're working any serious server-side configurations, you are going to deal with CLI. And CLI means the command line interface, and you will be dealing with the commands. So you need to do a lot of practice. So you become comfortable with the commands, their arguments, their options, and what are some of the important options, because there are many commands and there are many options available. So we will try to cover all the important ones, not only important commands but the important options that every command has in this particular live course right here, and then so that we can practice it as well with the hands-on approach, right? Now, any kind of software, operating system images, and lab instructions along with the solutions are provided in this course. There will be some labs also along the way, which I'm going to send you, and there will be a solution file as well, so you can try it yourself with the knowledge that you have gained with the commands and the practice that we do in this session. And then if you get stuck somewhere, you can always look for the solution file. Now, OS images, although I'm mentioning it here, but since we are also going to start with the installation, and we are also going to learn how to do proper installation of Linux operating system. So these images you can directly download from their particular vendors, because Linux is an open source software, and almost all vendors allow you to download it for free. So it's not something that you would need help with. Yeah, but yeah, of course, I'll help you with the links and all for a particular kind of image and all these things. But these are easily available on the internet, and I'll give you some guidance that which one you should start with. And of course, after today's session, you will have much better understanding that which Linux operating system means what kind of level you need to be on to start with certain Linux distribution, and that will help you to select your starting Linux operating system. Again, for this course, you can't go wrong, to be honest, because most of the commands are basic commands which are supported by all distributions. So it's not going to be a particular distro specific, right? Now, these live Zoom sessions are recorded also. and you can access these recordings on the portal, right, from the Zero to Linux Live, Linux Basics Live portal, and these recordings are available for lifetime. So don't worry if you miss something, or if you want to have a refresher on some certain commands or options, you can always go back to the recordings. Although the recording might not be from this class, it might be from one of the previous classes. But these are the same exact classes, and we actually cover the same exact commands and options. So you're not going to miss anything, and you will get the same information in the recordings as well, right? And of course, I highly recommend to join the Facebook community group that we have for Karotul for Zero to CCI. And this one, actually, the name is Karotul Study Group. If you haven't joined yet, you should join, because any question that you want to ask, you can ask there. And if I am free, I can answer your questions. If some students already know about those questions, they can answer you, or they might even benefit from the answers that are given to your questions. So it's a great place to ask questions and get answers. So highly recommended to do this. And of course, as I mentioned, you will have lifetime access to the recording. So anytime you want to get back to refreshing your lyrics knowledge, you can always come back to this, right? So this is the course structure we have. And since this is the lyrics basics course, what exactly do we mean by basics? What are we going to cover in this course? So what we cover in this course is starting from the introduction to Linux, like what is exactly Linux kernel, and what do we mean by Linux distributions, or in short, they call them distros? And what exactly is the DE, desktop environment? And how many different types of DEs are there? So that is an important aspect we need to understand before we get a specific installation and all these things. And of course, before we get to the installation, we also need to understand what are the Linux operating system partitions and different kind of directories. So you will see that when it comes to installation nowadays, there are so many options available that you can let that system decide how many partitions will be created, how many directories will be created. But you should be aware of the meaning of all the important directories, like what is exactly slash var directory, which is short for variable. What is the meaning of slash home or slash root directory? What is the slash temp directory or slash opt directory, which is the option or optional packages. So having knowledge of importance of some of the important directories and partitions become very important before you get to the installation, because we are also going to learn how to install Linux automatically, like let the system decide it, and also how to do it manually. Means we decide the partition scheme and the different formats, which is called the file system, like which file system we want to use. All these things we're going to learn into the installation part. So I would say this would be the first practical that we're going to do, the Linux installation practical. Once we have the enough information about kernels, distros, desktop environments, partitions, and directories. Of course, once the Linux installation is done, then we are going to start with the commands, right? So we are going to introduce the CLI and basic commands. And in the basic commands, we are going to cover a wide range of different kind of commands that you will need for your day-to-day Linux operations, right? It can be simply creating files and folders and directories, all the way to compressing large number of files so that it creates a single compressed file. And we can see different kind of compression mechanisms as well. We will see some commands to find specifically what exactly are you looking for. If you have lots and lots of commands, lots and lots of files and folders, we're also going to learn different kind of structure that we can use to create user accounts and manage permissions, create groups, and actually assign different level of access directly to the group, which can have multiple members. So not only just the basic commands, although it is called basic, but we're going to cover a lot of advanced commands as well, right? Uh, Another thing very interesting about Linux is package manager. Now, if you are aware of the Windows operating system, you know that we have software. Like you want to install a new app or you want to install a new software, you generally have the exe file, executable file, or .msi file, and you just double click on it and you install the file in Windows system, right? If you have a new game or a new application, you just install the software In Linux, the softwares are called packages, and the reason they call a package, because everything is a file in Linux. And generally, if you are trying to install a new software, it actually contains multiple files which depend on each other. So these are called the files and dependencies, and you need to install all of them for the software to work. That's why it's a package of different files, right? So in Linux, we don't call it software, we call it packages. And you install different packages if you want different features or different applications, right? And To install packages and to uninstall packages, to list all the packages that you have and which packages have what dependencies, all this information, if you want, you actually use something called a package manager. So we are going to learn how to use package manager and how to install, upgrade, delete, or get information about different packages. So that is also something we are going to learn into this part, right? And another very important thing we are going to understand in this course is the introduction to the Linux file system. Now, file system is how you actually create the file structure, file and folder structure in your operating system. So if you are using Windows, generally we use the FAT32 file system or NTFS file system, right? This is how you format your partitions. When you break a hard disk drive into multiple partitions, then every partition need to be formatted into a certain file system, which actually helps in indexing, deciding the minimum and maximum file size, and all these operations are regarding files and folder creation, right? So in Windows, NTFS is very common, right? Very popular, but you can also use FAT32 or FAT file system. On the other hand, in Linux, some of the file systems are very popular, like ext or ext2, ext3, ext4. There is a file system called XFS. There is one which is called BTRFS also. So what is the difference between these Linux file systems and the comparison between them, so that you can choose which one is the best one for your requirement? Or if you're working for an organization and they want your recommendation that which file system we should go for, you should be aware the pros and cons of different file systems, right? So we are going to definitely learn this part as well, right? So at this point, we are going to start getting into the more advanced stuff slightly, although the name is Linux Basics Live, but we will see some of the advanced stuff as well, right? Now, once the Linux is installed and you have some of the basic knowledge of the different commands, of course, you want to understand that what will happen if I have more than one users. Now, if you're not using Linux only for yourself, if you're actually installing it as a server, which will be accessed by multiple users in your organization or your clients, then you start need to understand the authentication and authorization. Authentication means verifying the identity of the user, like who the user is, who the user actually is, he is claiming to be. And also, once we know who the user is, what level of access that user should get on different files and folders. So that's why the next point, users and groups, become very important when it comes to securing your Linux operating system, right? So what is a user? User is an entity which can actually access resources. It's the identity of who is using your system. And group is actually, as the name suggests, the group of users, so that you can implement some policies to multiple users at the same time by applying the policy to the group rather than to the user, right? And we are also going to understand the importance of the root user account. And root user account is actually the super user who has all the power in the Linux operating system. And Linux, you will see, and one interesting thing is that Linux doesn't stop you to do anything if you are the root user. You can actually go ahead and delete all the important files also. Of course, your Linux operating system will become unusable after that. But the point is, Linux is not going to stop you from doing that if you are the super user or the root user. That's why it is, you will see in practice also when we start this course, that it's not a good practice to use the root user account for your day-to-day task. Because if somehow your system gets compromised, anybody who is trying to access your system will gain the access as the root user account if you are logged in as the root user. Also, when you try to execute some applications, they also temporarily take the elevation of the user who is trying to execute that application. So if you are a root user account or logged in as the root user account, any application that you execute will also execute as the root. So it's not a good idea. Instead, you should always use a non-root user account for your day-to-day tasks. And whenever you want to do something which needs the higher level access or elevated access or elevated privileges, then you can actually use a command called sudo. Sudo is short for switch user and do. So you can switch the user account to the root just to do that particular task, and then you automatically come back to the privileges of the non-root user account. That way, you secure the system from any unauthorized breaches. In case if somebody can access to your user account, that will be a non-root user account, and any applications that you are running will also be running as a non-root user account, so they will not gain access to the all-powerful root user account. Also, another benefit is that you accidentally don't do something that you are not supposed to do. You need to know that you are doing something with the root privileges by using sudo command. So that will make sure that you are aware, because it asks you your password also again, and you need to type the password. So you cannot do something accidentally as the root user account if you haven't logged in with that, right? So many benefits of this we are going to learn. And of course, once you have multiple user accounts created and multiple groups created, you can use them to for file and directory permission. File and directory permissions, they allow you to decide what level of access you're going to get on each file and folder. Folders are called directories in Linux. So when I say that what kind of access you're going to get on the files and directories, what it means is that can I just read this file or can I modify this file as well? What about renaming this file or moving this file, copying this file? Can I delete this file? All these operations. And what about the directories? I have 100 files in this directory. Can I just move this directory somewhere? Can I create more files inside this directory? Can I delete something? Can I delete the whole directory? What kind of access are you going to get on these resources? That will be decided by who are you, who you are, basically what is your user account, which group you belong to, and what level of permissions have been assigned to you, right? So that's why you can see file and directory permissions become very, very important. It's a slightly advanced topic, to be honest, not a very basic topic, but we are covering it here so that you become more comfortable with the Linux security aspect as well. It's a good starting point for that, right? Of course, one thing you will notice in Linux is that everything is a file. So the editors become extremely important. Editors means basically text editors I'm talking about, like your notepad in Windows. In Linux, you have so many different options you can use. But if you are just installing any Linux distro, few of these you will always get. For example, the VI editor, which is basically the name is Visual Editor, but ironically that is strictly CLI, and it's a very very keyboard centric editor. Means you don't use any GUI, you don't use any mouse, and even inside the VI editor, the old original VI editor, they did not actually even use the arrow keys to maneuver the cursor. Instead, you have to use your alphanumeric keys to do everything, even cut, copy, paste, moving back and forth, up and down, everything you do from the alphanumeric keys. So this editor has a slightly learning curve, but so many people love it because once you learn those things, it becomes even faster to do everything because you don't need any mouse or any special keys. Just your alphanumeric keys means alphabets, and the numeric keys, you just need those. Actually, to be honest, only the alphabetic keys are needed for everything that you need to do. So VI editor is very, very interesting. We are going to learn that as well. And if you want to go easy on yourself, you can go with the nano editor as well, which is much easier and use the special keys on your keyboard like control and alt and shift and then some certain things for your different kind of commands, right? So nano is slightly easier and it gives you all the options at the bottom of the window, so you know what command can be used to do what. So of course there are other editors as well. It's not just these two editors. There is like Emacs editor, which is used mostly for programming purpose because it is very colorful. It gives you a lot of options. There is gedit as well. So there are many, many options in Linux. But starting with Nano and VI, you can't go wrong. You will have a lot of information and enough information to edit any file and create any new files as well, right? And of course, we are going to get into slightly more advanced stuff after this. At the end, we are going to do some networking basics, like how exactly networking work, enabling communication, what is IP addressing, and we are going to use this to connect to Linux servers. So until now, all the topics I discussed about, you can use a single Linux operating system. You can just install VMware and you can just install a Linux operating system. It could be Red Hat, it could be Debian based, it could be Ubuntu or MX Linux or Linux Mint Pop OS. You can use any of the distribution and you can't go wrong. All the commands we discussed earlier, except the package manager, because package manager depends on the distribution type. But there are two major distribution types, Debian based versus Red Hat based. So based on that, you will see that there are two different types of package management. But mostly everything else you can do on a single Linux operating system. But for networking, of course, we will need at least two network operating systems. So we are going to use one Linux server and one Linux client. And again, these keywords, server and client, these are subjective, because in Linux, any implementation can become a server if you start activating those services, right? So it's not that one is a dedicated server operating system and one is the client operating system. Like people use the Mint OS as the client operating system, as a GUI to install different applications and different media codecs to watch Netflix or to watch YouTube and all. But doesn't mean that the Linux Mint Linux cannot become server. You can start installing Linux services which can make it a server, a web server, a file server, an FTP server. You can make it any server by activating those services, right? So every Linux operating system or every Linux implementation can become a server. So we are going to use two Linux operating systems. We'll connect them. We will enable communication between them. That will be the networking part. And of course, based on this, lastly, we are going to do a project. We are going to implement Linux web server, and of course, for web service also, you have many options in Linux. You can use Apache or you can use Nginx. You can use many other options as well. But Apache is one of the oldest and very, very popular web service. So we are going to install it and we are going to see how to access our web page from the other Linux operating system, or maybe even from your host Windows operating system as well. Right, so these are the topics we are going to cover in this basic class. And exactly what tools are we going to use for this? So the tools that we're going to use again are the same tools that we use in other classes also. We will use VMware. VMware Workstation Player will be fine, which is the free version. Or the Workstation Pro if you have, that is also completely fine. And for individual Linux operating system, that will be installed directly into the VMware using their ISO files. So unlike other classes where I provide OVA, where you can import it and you get everything working, because we want to learn installation as well, which will be one of the important topic of this class. We are going to download the ISO files from the respective websites of Linux distribution, and then we are going to install it into the VMware as an operating system, right? So speaking of it, which we can actually decide which one we want to install, and I'm going to send you a file. Let me show you that file. So this is the file I'm going to send you after the class. Links to download the Linux operating system. Of course, this is something you can always do a simple Google search, and you will see many different operating systems available there. But here I give you a basic guidance that there are two different family trees of Linux distribution. There are literally thousands of Linux distributions. So which one are you going to choose? So there are Debian-based Linux operating systems, and then there are Red Hat-based Linux operating systems. And the difference you will see only appear on a slightly higher level, like package management and all. Basic commands are same in both of them. For example, in Debian-based Linux, the command apt is used to manage packages like installing, uninstalling, listing. But in Red Hat-based Linux, we use yum or DNF keyword. DNF is the newer keyword. Yum was the older keyword. to install different packages. These are the different differences, right? Now, there are literally hundreds and hundreds of distros out there. Actually, there could be more than 1,000 distros now. So, which one are you going to use for this class? So, I give a slight introduction here as well. Like we can use the servers and clients. Client basically means that we install the desktop variant or more GUI based installation. Server is more CLI based. So, for server side, I actually recommend to use either RHEL 9 or Rocky Linux. And the reason I have recommended these two is because if you have taken the 52-week recorded course as well, then it will be a smooth transition once you are done with this and you're going for advanced stuff there, right? Because we use Red Hat Enterprise Linux there. So Red Hat Enterprise Linux version 9 is the latest one that if you use this one, it will be really beneficial for you in the future as well. But remember, RHEL, especially the enterprise Linux, is not a free version, although we know that Linux is open source, everything has to be free. So what Reddit does, it doesn't actually charge you for the operating system itself, but it charges you for the support. So you need to take a support because they think that you're using it for your organization. But of course, we are not using it for the organization. We are using it for practice purpose. So they do have a Reddit developer platform which allows you to download and use RHEL 9 for free for personal use, right? But of course, there is slight steps here. You need to create an account, and when you install RHEL, you need to register it using the subscription management register command in the CLI, and you need to provide your account details so that your system will get registered in your name. Or you can actually disable subscription manager if you don't want to go through these steps. So there are two or three ways you can use RHEL 9, and all of these are legitimate ways. Don't worry, there is no illegal way to use it, right? On the other hand, if you don't want to go through the hassle of creating an account or deleting subscription manager, you can decide to use Rocky Linux. Now, Rocky Linux is an open source enterprise operating system, which is designed to be 100% bug for bug compatible with RHEL. Means it is exact replica of RHEL 9, like Rocky Linux 9 is exact replica of RHEL 9. So you will get exactly same commands, same packages, everything. And it is completely free. You don't need to register anything and it is free forever, right? So it's better for practice purpose as you get the RHEL environment without the headache of registration and dealing with subscription manager of RHEL 9. I've given some links also. Of course, a basic Google search also will take you to their websites to download the ISO images that you want to install, right? So that's completely fine. There is another option as well. You can go with Alma Linux, which is also a copy of RHEL 9, but it is not exactly bug for bug copy, uh, but it is almost same as well. So feel free to choose between RHEL 9, Rocky or Alma as your starting point. But again, let's say if you already have Ubuntu installed, or if you already have Debian installed, or if you already have Linux Mint installed, you can use that as well for most of the commands that we are going to do in this basic course. Because as I mentioned earlier, the basic commands are always same, right? Now for the client side, again, there is no logic of server and client. It's just what services you install, but more desktop environment heavy, I would say, which give you a very nice GUI and everything. You can decide to go with Fedora, which is actually the RHEL project, Red Hat Enterprise project. And you can also go with Linux Mint, which is the desktop client OS, which is based on Ubuntu, which itself is based on Debian. So basically, you have two options: Red Hat based client and Debian based client. Uh, and Linux Mint, to be honest, is better because it provides full out of the box multimedia support, and it gives you more like a Windows 11 kind of vibe, right? And you can also go with Linux, MX Linux. I'll give you different options more, but these are two that I recommend to start with. But of course, if you use anything else, you can't go wrong, right? This is just the introduction and just a recommendation from my side. So this file also I'm going to send you so you can read it and then get some basic information and links to download your files. So this is something I'll send you today. So for the VMware, just make sure that when you install VMware, you set the network type to NAT, so that when we connect more than one Linux servers, we can enable communication between them, and they can also communicate with the host operating system, like whatever the Windows. Like I'm using Windows 11, I can connect to my Linux servers, ping them. They can ping to the Windows machine if you use the NAT type of network selected, right? And for most part of the course, only one Linux machine would be enough for the basic commands for permissions and all, installation and all. But of course, for the networking part and for the project that we will do, the Apache Web Server project, we will need a server and a client. Right. So although VMware is recommended, as I mentioned, but if you decide to go with VirtualBox, which is another hypervisor, you can use the bridged mode in that instead of the net mode for networking, and that would be a better option, right? But if you decide to use VMware Workstation, then you can go to the settings of the VM, and then you will see you can select the network adapter as NAT. And also the for memory, you can decide how much RAM do you want to assign to your system, right? To your Linux operating system. Now, if you are using it for the GUI heavy machine like Linux Mint, or you want to use it for many GUI features, graphical user interface features, then it's better to use at least 4 to 8 gig of RAM. But for Linux server side, if you're just using CLI, then even 2 gig RAM is also enough. Linux is not very um, strongly resource heavy. It actually can work without much resources, to be honest. So 2 to 4 gig should be more than enough for that, right? All right. So at this point, we are going to take a small break, and after coming back, we are going to start with the Linux introduction. So today, I'm just going to introduce some basic things about Linux, and to understand the different kind of distributions that Linux distributions which are there, right? So few minutes break,
Yeah,
and we'll be back, right?
sure. Yeah.
All right, thanks. So, after the introduction to the structure of the course, now let's introduce some of the basic stuff about Linux, because, as I mentioned earlier, the very first thing we'll do, like from the next week, to understand the files and directory and the partition structure, so that we can understand if we have to decide to install Linux manually, what are the different options. And then one of the first practicals that we are going to do is going to be the Linux installation practical. But before that, of course, we should know what exactly is Linux, and what are the different options that we have when it comes to using Linux, because there are so many options. You get sometimes confused that which one should I use, where should I get started, right? So today we are going to see that what is the difference, pros and cons of different kind of distros as well. So Linux itself is actually a family of free and open source operating systems based on the Linux kernel. So in today's world, whenever you're using Linux, you are not actually just using Linux. You're using some distribution based of the Linux kernel. The Linux kernel is the core operating system which directly deals with the hardware, which communicates with the hardware directly, and also provides you an interface to provide commands and instructions, which we call the CLI and the GUI, right? So the operating systems based on the Linux are known as the Linux distribution or Linux distros, right? So they are based on Linux, means that they are using the Linux kernel in one way or the other another. Now Linux kernel is free and available to everyone. So if you have enough knowledge also of programming and operating system implementations, you can create your own distro as well by using the Linux kernel, which will allow you to create the shell. Basically, it's creating the outer shell and the package management and how exactly it will look and feel, what features it will support. That is something you can slightly change, and that will create a new distro. That's why there are so many distributions, but they're all based on the Linux kernel. So the Linux itself, it was initially released by Linus Torvalds on September 17, 1991. So what was happening is that there was a operating system before this, which is called Unix. Unix is basically the father of all the operating systems, which is created in C language, which is called the mother of all the languages or programming languages. But the problem with the Unix was that it was not free. It was not an open source project, and you had to purchase it to use it. So Linus was using Unix in the organization, but he wanted to do some project on his own, and he found out that he cannot do it without paying huge sum of money to use Unix on its personal computers. And that's where he thought, okay, let's create something which doesn't need any kind of licensing, or a very free GPL, which is called GPL licensing, will allow GNU general public license to actually do that. So that's why Linux is a free and open source operating system, and the source code can be modified and distributed to anyone commercially or non-commercially under the GNU GPL. Now, commercially means you cannot actually sell it, just like Red Hat Enterprise Linux or Debian or different kind of implementations. They do have some plans where you need to pay, but you actually are paying for support, so that they can actually help you if you get stuck somewhere and to fix the issue, which can become extremely important if you are using it in a production environment, right? So if you are actually implementing Linux for a very, very important server, which is actually providing services to many, many clients and customers, you don't want to sit there and try to troubleshoot it yourself when you're stuck in the in the important time of when the client needs it, right, or the customer need it. So it's better to get some support at that time. At that And that's what they charge for the support and to give you some technical assistance, right? They cannot actually charge you for the operating system itself because it comes under the free licensing or the GPL. You'll see that initially Linux was created for personal computers. So it's actually ironical because Linus thought, okay, I'm going to use it for PCs, personal computers. But today, most of the servers, mainframes, computers, and even supercomputers, they work on Linux operating system. So it's a very, very popular server-side operating system it has become. That's not what Linus thought initially. But of course, it has become a revolution after that. So nowadays you will see that Linux is used in many, many different kind of implementations, not only just on the computers, but also in routers, automation controls, many TVs, DVRs, video game consoles, smartwatches. So many different implementations use actually Linux as the operating system. One of the biggest success of Linux is actually Android operating system that we use in our Android phones, right? So if you're using an Android phone, you are actually using Linux, which was the core for creating the Android. So if we see the history of Linux when it was released and comparing it to other operating systems, you will see that back in 1969, the Unix was released, and then MS-DOS was released, which is the Microsoft operating system. 1984, Apple System 1 was released, and in 1991, Linux was released by Linus. And Mac OS, which is the Mac operating system from Apple, was released in 2001. The version that we are using now, that is based on the 2001 release, right? But of course, as I mentioned, that although it was intended for personal computers or PCs, it is actually used now as the server. So what are the different servers that we can see the Linux implementation? So there are many implementations you will see for web services. It's very, very common server. Name resolution, DNS, name to IP resolution. You can create it as a DNS server as well. File server for storing business data, usually in some form of text documents, and also transferring files and print server, logging and virtualization and containers. Logging is actually very, very important aspect also, because you need to understand that whenever you implement some policies, you need to know if these policies are properly enforced or not. If somehow somebody was able to successfully breach the policies, or if somebody is trying to access something, unauthorized access is trying to be executed. So all these things you can see into the logs, and you have to save the logs or store the logs somewhere. Linux server can be a great syslog server, system logging server as well. And virtualization, we know, is to compartmentalize your hardware, by creating different operating systems using the same common hardware and sharing it between them, or even containerization. Container simply means not a separate isolated operating system, but a separate isolated application with all of its dependencies, so that it can run anywhere, and it doesn't depend, or it doesn't actually completely rely on the underlying hardware. So Linux is very popular in that part as well. It is also used as a database server, or as a cluster. So cluster basically is to connecting multiple servers together and providing the same service. So whenever a request comes, it will come to an IP address which is represented by multiple servers, and whichever server is more free, has more resources available, will actually take the request. So it will look like you are going to a single server, but you are going to one of the servers from the group of servers, which is called a cluster. So there are so many different ways you can implement Linux service. But of course, to do any of these things, you have to choose which Linux distribution you are going to use, right? Because as I mentioned earlier, that you cannot directly use the Linux kernel, right? You need to have some kind of outer shell, which is called the CLI, and the GUI, which is also known as DE, desktop environment, and a package manager to install, update, delete, and maintain the softwares. So that is called a distribution, a Linux distribution. So Linux kernel, as I mentioned, is packaged into one of the Linux distributions, which creates basically the outer layer of the operating system, the shell of the operating system. And this is an operating system that is made up of a collection of softwares based on Linux kernel. So you can also say that Linux distribution contains the Linux kernel and supporting libraries and software. Now, software is the package, as I was mentioning earlier as well, right? This is basically a certain application that you want to use. But what exactly do we mean by libraries, right? Software, what is the difference between package and library? The package is dedicated for a certain task. Let me give you an example. Let's say I want to watch some movies on my Linux Mint operating system. So I install the VLC player or any other player, right? The media player. Now that VLC player is the package or the software, and I might also install two or three other softwares which also can play media, audio or video. Now there are so many core things, or we call the codecs that are needed by all these different media players, whether audio or video. So if there are some certain part of the code which is needed by multiple softwares, then we can create it as a library. Library is the shared code or piece of code which can be accessed by multiple packages. It's not actually linked to a single package. And these libraries are the core features of the operating system, which might be used by multiple different packages. So you can have common libraries accessible by multiple different packages from multiple different softwares. So if you are from the programming background, you might know about the keyword we use in programming called functions. And functions are basically a piece of code that can be called again and again by different part uh, of the program, or different programs as well, different codes as well. So that is called calling a piece of code again and again. Like for example, if I have to take the square root of something and I create a logic and I create like 10 lines code which can get the square root of a particular number. And anytime I want to take the square root of a number anywhere in my program, I don't need to write those 10 lines again. I can just call that function, and then it is going to perform that thing. The libraries are similar. They are codes which can be called upon by different packages or different softwares. So speaking of different kinds of distributions, you will see that there are different types. Like there are core distributions or core distros, which are there for long time. Some of them are right there from as old as the Linux itself. And then there are some certain distros which are created for some specialized use cases, which are called the specialized distros. And then there are some which are called live CD distros. Means if you don't want to install Linux If you just want to play around, you want to just get a feel of it and get comfortable with it first, you can directly run it from the CD or nowadays from the USB drive. And basically, you are not installing Linux on your main computer. You're installing it on the USB or CD. And when you insert the CD or USB, you can start using that Linux operating system without installing it on your hard disk drive. So that can also be a method to implement and learn Linux operating system, right? So that actually brings us to very important part, that what are some of the major distributions which are out there. Now there are literally thousands of distros there, and you can go to the distrowatch .org or distrowatch.com, I think, and you can also do a Google search, Linux distributions, latest distributions, and you will see that how many different distros are there. But some of the major ones are very important, and most of the distributions that come out, they are based on these core distros as well. For example, you will see that you must have heard these names: Ubuntu, Linux Mint, and MS Linux. These are considered the easiest for new users. So if you're new to Linux, these would be a great choice to start with, because they also have a nice GUI, and they have a very, very detailed uh, support on the internet. Like there are documentations. If you get stuck into something, you will, like in Ubuntu, if you get stuck in some certain things, it is almost guaranteed that there is some document or some discussion, some forum on the internet where this problem has been discussed, and more often than not solved as well. On the other hand, you can go to the other end of the spectrum. There are some very, very complex Linux implementations like Arch Linux, Gentoo, or Slackware, which are advanced distros, right? They need comprehensive knowledge of Linux before they can be used effectively, because you build them from scratch, and they have some certain specific use cases also. Like Gentoo is used for networking and programming purposes mainly. Arch Linux, you need to compile everything from the scratch, and they have a rolling release, so you don't actually get a new version of Arch. It keeps on updating things in your system if you're connected to internet, and sometimes that break things. And one day your Arch Linux is working fine, next day everything is broken, and you need to fix it, which can take few minutes, hours, or even days. So if you hate your life, you should use Arch Linux. That's what people say, which is of course a joke, but it's a great tool to learn advanced stuff. So once you get to the advanced level or slightly more comfortable with Linux, you can definitely play around with Arch Linux, Gentoo, or Slackware. But these are on the other end of the spectrum. If you are completely new, don't use these right away, right? And then we have somewhere in the middle, like OpenSUSE, Fedora, Red Hat Enterprise Linux, and Debian. They can be considered like mid-level distros based on the difficulty and the learning curve. So they are not as difficult as Arch Linux, but also not having many like codec supports, or not GUI based, unlike Linux Mint, MX Linux, or Pop! OS. So some of the Linux distros that you should be aware of, like the major ones, Debian Linux, which is one of the oldest one, I would say, after Linux itself. It was developed in 1993 by over 1,000 volunteers, and it actually contained close to 50,000 binary packages. It has inspired more than 100 Debian-based Linux, more than 100 now actually, Debian-based Linux distributions and live CDs. So many different, very, very popular Linux distributions actually are based on Debian. For example, Ubuntu is based on Debian itself as well, which is a very, very popular Linux operating system. So there are three main branches here in Debian. There is an unstable branch, which is called the SID, and this one is released with new features, but it's not guaranteed that these features will work or not going to break your computer. Then there is testing one, where most of the features are tested, but the testing is still going on, so there is no support. And then there is a stable one, which has been there for some time, and people have and communities have properly checked it, and everything seems stable in the operating system. So there are three different types of Debian you can install. So the one of the benefits of Debian is that it is very stable and very high level of quality control is using this, and it also supports more processor architecture than any other Linux distribution. So if you're using one of the older processing architecture, you can rest assured that Debian does support it, including the newer ones as well. One of the drawbacks of Debian is that newer technologies are not always included, and it has a very slow release cycle. So every stable version actually takes some time before the new one comes. So it's not up to the date or supporting all the latest features and technologies. But again, if you're using it as a server side implementation, you don't need all the latest and greatest features all the time. So that is actually fine. The other big player is, of course, Red Hat, which had created a project which is called it was actually introduced in 2004, but before that, it was known as Red Hat Linux, and actually it dates back to 1995. And this project implemented or introduced the RPM package manager with dependency resolution and other advanced features. Before this, it was a nightmare to install packages because if they depend on other files or other libraries, you had to install them first. And if they depend on something else, you need to install them first. So it was a nightmare to install packages in Linux before RPM. But RPM was a high level package manager which allowed you to do the dependency resolution automatically and install the packages easily. It actually revolutionized package management. Fedora is highly innovative and it has outstanding security features and large number of packages are supported, right? Although Fedora itself is considered to be like the client side operating system or more for the implementation checking purpose before it becomes part of the server, you will see that it tends toward enterprise features more, and it is considered to be a test bed for enterprise Linux rather than desktop usability itself. So if you want to go with a server side operating system, a full on server side operating system, you can also definitely go with Red Hat Enterprise Linux, which is from the same organization Red Hat, but it is the downstream distribution of Fedora and CentOS Stream. So Fedora and CentOS streams are used for checking new features, and then if they are found to be stable and suitable for the server, then they are actually released into the next Red Hat Enterprise Linux stable version. So the one thing which is different about RHEL is it is commercially backed and supported. Of course, there is a fee for that, and the support is generally for 10 years or more. So it's actually a very good deal. You actually get technical support from RHEL. But if you're using it just for testing purpose, as I mentioned earlier, you can definitely use a free developer license, which is available, right? It uses the DNF package manager, which is based on RPM. Of course, RPM is the Red Hat Enterprise Linux package management implementation, and DNF or YUM, these actually depend on the RPM itself. On the other hand, you have also OpenSUSE, which is also one of the very old distribution created in 1992 by four German Linux enthusiasts. And it has two main editions, Leap and Tumbleweed. And it has comprehensive and intuitive configuration tools as well, large repository of software packages, excellent documentation, and it actually depends on Red Hat Enterprise Linux RPM package manager. So it uses RPM package manager, and sometimes it is considered bloated and slow as it has resource heavy desktop setup. Right? So for the desktop implementation, it's not a good choice, but as a server, which is like a headless server, no GUI, only CLI, it's a great choice. And then comes a very interesting one, which is called FreeBSD. An honorary mention here because, to be honest, it is based on the Berkeley software distribution. So it is the tightly integrated OS built from a BSD kernel. It's not actually built from Linux kernel technically. So it's not a Linux distro. It's a BSD distro. BSD is a separate kernel. It's not a Linux kernel, but there are quite similarities between these two. And That's why you will see that if you're using FreeBSD also, some of the core commands are going to be same. One of the good thing about FreeBSD is it is very fast, high performance, and extremely stable operating system. That's why it is very popular on the server side, suitable for web servers and even for search engines. And it is much less restrictive also as far as the licensing is concerned compared to Linux. Like you can recreate and redistribute FreeBSD as much as you want. It has more than 24,000 software applications which are called ports, and it is a very good documentation as well. One of the drawbacks of FreeBSD though is that it lags behind Linux in terms of support for new hardware and limited availability of commercial applications, and any lack of GUI tools actually make it not very popular for any new users who are learning Linux operating system, right? And then comes some of the client side. I say client side because it is more desktop heavy, but of course you can install it as a server as well. So Linux Mint, which is based on Ubuntu, and it has a good collection of tools developed in-house and support for features and multimedia codecs. Multimedia codecs is what makes Linux Mint very, very popular, because if you're using it as a desktop operating system, you want to watch Netflix, you want to watch YouTube, you want to have proper audio and video codecs to support all the applications, which is right there built into Linux Mint or installed with Linux. That is based on Ubuntu, which is itself based on Debian Linux. So it is the Debian based operating system, basically. And one of the great thing about Linux Mint is that it is open to user suggestions. So many times people actually recommend things on their forum, and they do implement some of the interesting things into the next release. One of the issue with Linux Mint is that it doesn't issue any security advisories. So it might not be a good idea to use it as a server, because the security advisories are not there. So if there is a security breach, you might not be able to find it out if you are not proactive. So on the client side, it is okay, but server side, because of the lack of security advisories, it's not a very good choice for that, right? On the other hand, Ubuntu is very, very popular. It is Debian based, which is based on the SID branch or the unstable branch of Debian. And it has a fixed release cycle and support period. So there are two different types of Ubuntu implementation: non-LTS and LTS, which stands for long time support. So if you're going for long time support Ubuntu, you will get the support for a long time. Basically, it is a cycle, and until the next release comes, and out, even after that few years, you will get the support for Ubuntu. One of the great thing about Ubuntu is that it has extensive documentation online, both official and user contributed. So anytime you get any issue, you can guarantee that you will get a solution on the internet. Someone already had this issue, and they already have a discussion about this, right? And although it is Debian based, but it lacks the compatibility with Debian, so it is not compatible with Debian operating system. It just uses the package management like apt command from Debian. And then there are some others like MX Linux, which is also Debian based, but based on the stable branch. And it is a result of a merger between Mapis Linux and Debian based Antix. And it has out of the box support for graphics drivers, browser plugins, and media. If you are installing it on a computer which has a graphics card, MX Linux will more often than not will support NVIDIA graphic cards, and has high chances of to be able to use it as well. It has a stable core with the updated desktop application, so it's a good choice for the client side operating system. Then of course comes Arc Linux. As I was telling you earlier, that this is one of the difficult ones because it actually needs you to compile everything. And this one uses the rolling release. So rolling release means there is no definite versions like this release version, and the next year or couple of years another one. Every time they keep on updating your existing version by adding new features every now and then, which is called the rolling release. And the package manager is called Pacman. highly customizable, which is why it is very popular to learn Linux. If you want to learn a lot of things, it's a great tool. But occasionally it is unstable due to the rolling release model, and the risk of breakdown means everything is working today and tomorrow everything will break. That can happen, and that happens a lot in our case. Then comes some special use cases, Linux like Gentoo Linux I was telling you earlier. This is geared towards the developers and network professionals. Uh, it typically set up with bare minimum set of pre-compiled packages, and then you need to compile everything that you need manually. The package manager is called Portage, which is Python based and which supports many advanced features, right? Highly customizable, very flexible, and able to use a range of compiled time configurations, init systems, and can run on many different architectures, which makes it a extremely useful tool if you are an advanced Linux user. Of course, that's why I was saying that it requires a higher degree of knowledge to use, upgrade packages, and even day-to-day maintenance need slightly more knowledge of Linux than normal. Similarly, you have Slackware, which is highly stable, clean, and mostly bug-free. But the problem is that it has limited number of applications and it has a complex upgrade procedure. So again, slightly advanced level of operating. So I was mentioning earlier that for this code, you can go with Red Hat Enterprise Linux or Rocky Linux, which is the free version of RHEL. And for the client side, you can go with either Fedora or Linux Mint. That should be a good starting point. Now, everything looks great with Linux, but what are the different pros and cons of Linux if we think about it? Like the pros, we can see clearly that it is very stable and it is used as a server all over the world. But what are some of the pros and cons that we should be aware of about Linux? So let's talk about the advantages. So it's an open source operating system, right? That means you don't need to pay for the operating system itself, and there is no like yearly subscription or anything. So no cost involved at all as far as the operating system itself is concerned. And it is more secure than any other operating system. And the reason is because the core of Linux is that everything is a file, and securing files based on the Linux based on the user accounts and groups and elevation of the privileges, that model actually makes sure that it becomes extremely secure. But again, this depends on your implementation style and the policies. It can become unstable or unsecure as well if you are not properly implementing all the policies. Right? And the software update in Linux are easy and frequent. So anytime there are new features, you can rest assured that you will get them for free of cost because Linux itself is free. And there are many distributions to choose from, so you can use them according to your requirement or according to your taste or according to the requirement of your organization. You have a large number of distributions to choose from, and it is a huge community support. So anytime you have any issue, you know that there are literally thousands and hundreds of thousands of people out there who can actually help you, uh, commercially or non-commercially both. One of the things that actually make Linux stand out is the high stability. You wouldn't even believe that there are some Linux servers which are working for 10 years, 20 years, and they have never been rebooted. They have never had any issue at all, and they are still working fine. So it is extremely, extremely stable operating system. Once it is done, implemented, set up, it works as it is supposed to work. Linux is compatible with a large number of file formats as well. So that makes it also very easy to use. Not only just the Linux operating system, but it can also interact with Windows and Mac OS, and it supports those file formats as well. It is fast and easy to install from the web. It can also install on any hardware, even on your very old computer system. So if you have a very old PC, you can't install Windows anymore. But Linux, you can use as a CLI based Linux, and it uses very, very low resources. So you can definitely use that. What about some of the disadvantages of this? So of course, it is not very user friendly. So it may be confusing for beginners, but this is changing also very fast. So like 10, 15 years ago, you can say this, but now it is changing very rapidly and it is becoming more and more user friendly. Like some of the implementation, like Linux Mint or Pop OS, they are very, very user friendly, just like Windows. And it has a small peripheral hardware drivers as compared to Windows. So sometimes you might face some issues in finding the drivers for very new hardware or new peripheral that Linux still doesn't support. But that also changes very fast because many users start complaining and they need to come up with the new drivers for their hardware. So it doesn't become actually a problem in long term. So let's actually see what are the different components we have into a distribution. So if you decide to use one Linux distribution, what exactly do we get into that distribution? So in a Linux distro, you will get the kernel, of course, which is the core. It is directly in charge of the hardware and it controls the CPU, RAM, and any peripherals and server and serves as the brain of the system and communication link between the hardware and the software. And then we have the DE, the desktop environment, which is basically the front shell for the user experience, right? It decides the overall visibility and the visual layout of the OS. Examples would be the Genome, or Cinnamon, Mate, Pantheon, Enlightenment, KDE, which is K Desktop Experience, and XFC. These are the different names of how the system will present the Linux operating system to you graphically. You'll see that every DE or every desktop environment has pre-installed programs like file manager, configuration tools, web browsers, games. So speaking of the Ds or desktop environment, we have different options like Genome, which is very stable. It has regular updates and it has an active community and it has lots of apps also directly in there. Another option you can go with is KDE or K desktop environment, or also known as KDE Plasma. So if you don't have much RAM, you can decide to go with KDE because it is slightly lightweight comparing to Genome, easy to use, and highly customizable. Although it is lightweight, but it has a highly customizable interface and very active community of user. And because it is lightweight, it is super fast and visually is very appealing as well. So if you are not into very detailed GUI use cases. You just need some GUI to get things done. KDE can be a better option than Genome. But if you do have more RAM, then Genome would be a better choice. And then there are other options as well, like Mate. This is actually also very lightweight desktop environment. Again, this is also like resource efficient. And if you just want a GUI again to get things done, it can be a great resource for servers. And of course, it's a very old one, so it's time tested and supports a full set of applications. Another example would be XForm's common environment or XFCE, which is also lightweight, stable, user friendly, and the graphics are less modern. But again, that means you need less memory to support XFCE, right? So which one should you choose? Well, these are the different options, and you can't go wrong with one or the other because anyway, it is just the way you access your operating system from the graphical user interface. So you can't go wrong. But Genome is the most resource heavy among all of them, right? And that brings us to the So CLI basically is the command line interface where you can type the commands and get things done instead of GUI. So of course, Linux administrators prefer CLI for most of the tasks as it provides many benefits, different benefits like it is quicker. Of course, it consumes fewer hardware resources. It's scriptable, which is a great advantage. You can script things up and automate things because of that. And some of the disadvantages of this would be it needs a learning curve because, of course, Unlike GUI, where you see so many things, you can click here and there. In CLI, you are staring at a blank screen with just a with just a cursor blinking. So you need to know your commands and options already before you can start using them. Of course, there are help and everything, context sensitive help and documentation. But yes, there is a learning curve in CLI. Uh, that's why it is non-intuitive. You don't see anything; you just see a blank screen. And you have to type every time the commands with the proper syntax, with the structure and correct options. So you can make some syntax mistakes if you are not aware of the command. That takes us to the first point, learning curve into the CLI. But of course, CLI is very, very useful, and server side, we actually use CLI a lot. And how do you use CLI? You actually use a shell, and you can use the bash, born again shell, or K shell, G shell, C shell. There are many different shell, which is just the method they allow you to access the. So you see that there are many different options in shell. The CLI is provided by a software called a shell, and this actually accepts the user input, processes the input for syntax, and then provides the output back to the user, right? So you see the default shell for most of the Linux distribution is bash or born again shell. And the command syntax for bash is you type the command, which is the primary instruction given to the system. Then you type any sub command, like a secondary, more detailed instruction supporting the primary command. Then you can type some options to modify the output slightly, the way you want it to be modified. And then you can optionally also provide an argument. So this is the object on which the command will act. Some commands do not even need any argument, but some commands can need it. Like ls command list, which can list the directory and files into a directory. So you can use the command ls space let's say text file text one dot sorry file one dot txt. So it is going to show you the content of the file one. Oh, sorry, it is going to list the file one if it is there, and it will tell you the detail about the file one, not the content, but the detail of the file itself, right? But I can modify it by using some option like ls-l, so to do a long listing to get the more detailed information. And the argument here is the file one.txt because I want to know all that. But I can also type just ls and press enter, and it will list all the files and directories. So I can also type the command without option and argument as well in some cases. On the other hand, when you think about GUI, it consumes significant hardware resources, specifically memory and processor time. That's why on a server, these resources should be dedicated to the services it is providing, right? And generally, most of the servers are CLI only because of that. Desktop systems might need a user-friendly GUI, like if you're using it for your day-to-day tasks, but servers usually do not need it, and they do not install the desktop environment, which is the GUI solution, as discussed before, right? So that's it for today. I wanted to introduce the course, and I wanted to introduce the Linux distributions and the different terms that we use. From the next week, we are going to start understanding important aspect of Linux before installation, so that we can get to the installation with the proper knowledge, right?